I'm Vaibhav Singh, a third year undergraduate at IIT Roorkee from Engineering Physics, and today I'll be presenting on LDR sensors. So, first of all, we'll start with the introduction. So, a light dependent resistor LDR or a photoresistor or a photocell is a light controlled variable resistor. That is, its resistance changes with the light intensity that is falling on it. So an LDR exhibits photoconductivity. And what is photoconductivity? It is that the resistance of that LDR decreases with the increasing incident light intensity. So LDRs are made up of semiconducting materials having high resistance. Therefore, their sensitivity varies with the wavelength of light incident on them as well. So now we'll see the working principle of an LDR. So an LDR works on the principle of photoconductivity. Photoconductivity is an optical phenomenon in which the material's conductivity reduces or the resistivity increases when the light is absorbed by the material. So when light falls, the photon fall on the devices and the electron in the valence band gets excited to the conduction band of the semiconductor. So when photons of the incident light fall on the semiconductor, those photons must have higher energy than the band gap of the semiconductor to make the electron jump from the valence band to conduction band. So when the light having enough energy is incident, more and more electrons get excited to the conduction band, which results in large number of charge carriers. So the result of this whole process is more and more current. So hence we can say that the resistance of the device has decreased. Now what are the characteristics of LDR? So LDRs are light dependent devices whose resistance decreases with the light falls on them and increases in the dark. So when a light dependent resistor is kept in dark, its resistance is very high, and when it is allowed to absorb light, its resistance will decrease drastically. And it is shown in the graph too that the resistance versus light intensity graph nature is hyperbolic, and if a constant voltage is applied and the intensity of light is increased, the current starts increasing. Now what is the construction of LDR, like how is it constructed? So modern LDRs are made up of lead sulfide or lead selenide, indium antimonide, and most commonly cadmium sulfide and cadmium selenide. So a light sensitive material is deposited on an insulating substrate such as example ceramic. The material is deposited in zigzag pattern. So why zigzag pattern? Because zigzag pattern helps in separating the metal deposited area into two regions and also to obtain the desired resistance and power rating. So that was the construction of LDR, simple construction. And now we'll see what are the advantages and disadvantages of light dependent resistor. So the sensitivity of a light dependent resistor is very high. Even if we change the light intensity by a bit, the resistance changes by quite much value. So it is very sensitive. It is very simple and the device is very small, and it can be used very easily because the resistance simply depends upon the light intensity falling on it. So it is very easy to use. It is very inexpensive and cheap because the equipments are very simple and there is no union potential, and also the light dark resistance ratio is very high, so it is very easy for the LDR to differentiate between light and dark environment. Now disadvantages. So hysteresis effect is one of the disadvantage, and low temperature stability for the fastest material is also another disadvantage, and the variation of value of the resistance also has a delay. It is also one of the disadvantage of LDRs. Like when it goes from dark to illuminated or vice versa, it takes some time to change the value or to get the value of the LDR's resistance changed. So this slow response is a disadvantage for LDR. Now what are some applications of LDR? So LDR can be used as an audio compressor. So audio compressors are the devices which reduce the gain of audio amplifier when the amplitude of the signal is above a set value. This is done to amplify soft sound while reducing the loud sounds from clipping as well. So LDRs are used in audio compressors. This is one of its application. Another application is fire alarm. So the alarm works by sensing the smoke produced during fire. So when smoke is produced, the light coming from the bulb will, its intensity will decrease, so the LDR resistance will increase. So we can know, like, when there is smoke, the LDR can know when to ring the fire alarm. Now another example is light sensor. So the LED lights up when the intensity of light reaching the LDR resistor is sufficient. Example, in automatic street light, where the street lights on the street are automatic. They sense darkness. When they sense darkness in the evening, they turn on automatically, and when they sense sunlight in the morning, they turn off automatically. So this is also an application of LDR. So that was all of LDR from my side. I hope this video was helpful. So thank you for listening.